Hello everyone. So today we will discuss few exercise problems on orthographic projections. The first problem, which is displayed on the screen. So the arrow, it indicates the direction of observer to see the front view. Accordingly, we will decide the side view of the object. Since this direction is given to see the front view, so the visible side view will be left hand side view. We will use third angle method of projections. So we will have front view, exactly above front view we will have top view, and left hand side view, it will appear left hand side of the front view. So let us start this problem. First step, to find out the dimensions for front view, top view and side view, that is length, height and depth. Length dimension, which is seen in the front view, which is across the direction of arrow. So this is the length of the object. Height is a vertical dimension and depth is nothing but the dimension which is along the arrow. In front view we can see length as well as height of the object. Top view we can see the length and depth of the object. Side view we can see depth of the object and height of the object. So each view one dimension will be common. For example, front view and top view length will be common, front view and side view height will be common, and side view and top view depth will be common. So let us find out the dimensions by enclosing this object in the given box. The object is single piece object and it is formed from the number of surfaces. So I will try to accommodate this particular object in the box. This is the topmost corner of the object, so I will take the height dimension. I will move along the principal axis. Now this object is accommodated in the box, so I can find out the dimensions for the box. For example, length 1, 2, 3, 4. So here our unit is nothing but the grid space. So 4 grid space is the length. Height is 1, 2, 3, 4. So 4 grid space is height. Depth is 1, 2, 3, 4. So box is of length 4 grid space, height 4 grid space and depth 4 grid space. So accordingly we can draw the boxes for front view, top view and side view to ensure that our drawing will not go outside those boxes. So I will draw first box for front view. So this box is 4 by 4, 4 grid space is length, 4 grid space is height. Similarly, exactly above the front view, we will have top view since we are following third angle method of projections. So leave 1 grid space between the front view and top view, the distance between front view and top view, and both should be vertically aligned. Similarly, leave 1 grid space between front view and side view, so as those should be horizontally aligned, and since it is third angle method of projection, left hand side view, it will appear left hand side of the front view. So now I am sure that my drawing will not go outside of these boxes. So let us start with the front view. I can see the front view in the direction of arrow. So this is a principal surface which I can identify. This is inclined surface, this is principal surface, this is inclined surface, this is principal surface. So front view, I can see area view of this principal surface as well as this principal surface. I know height of this principal surface from this corner is 2 grids and it is along the complete length. Height of this principal surface from bottom plane, it is 4 grid space. So accordingly, I can draw. This point is 2 grid space from the bottom plane and it will appear on this line. Accordingly, I can make a drawing. From this corner, 2 grid space we can move and we obtain this particular principal surface. Now let us draw this principal surface. Now you see this corner and this corner will appear a single corner in the front view. So we start from here, we will go along the height 4 grid space, and this corner, if you see, it will coincide with this corner, that means this corner. Now we have drawn both the principal surfaces. Now we will see that other surfaces. This is a principal surface which will fall into a line view, which is automatically satisfied here. The inclined surface, it will fall into a line view in the front view. So it is also satisfied. This inclined surface also fall into a line view, that is also satisfied. So all surfaces are satisfied here. Let us now start the top view. Top view, I can see this inclined surface and this inclined surface, and apparent area can be seen. I can locate those points. Okay. So top view will be very easy here. So it is from this corner till this corner, which will cover entire length of the object, and along the depth 2 grid space for this surface. Similar way for this surface. So I can draw this is the area view for this particular surface. Similar way, area of the view for this surface will be similar. So this is top view. Now if you see, all other surfaces are satisfied. Coming to the side view, I can see this principal surface which is running along complete depth, height is 2 grids, and then this inclined surfaces which can be seen in the side view. So let us draw the principal surface. This inclined surface, other inclined surface here, if you see, this is the depth is 2 grids, height is, it will run from 2 grids. So this point it will appear here, this particular point will appear here. Now what about this inclined surface? This is a surface, the point I can identify, this particular point in the side view, it is here. So however, this surface is not visible. So what we can do, we will show it with the hidden lines. So what we do in our drawing, we will indicate hidden drawing with the red color instead of changing the line type, because it is easy for identification. So wherever the red color is seen in the drawing, that means it is hidden line. So that color code we follow throughout the course for orthographic projections. So we can do the finishing for the object by removing the lines which we made. So this is a complete object. Coming to the second problem. So second object, again what we will do, we will follow the third angle method of projections. and direction of arrow, it will indicate the front view. Side view, it will be seen from this direction, that is left hand side view, which is visible. Okay. For this problem, we will identify the principal surfaces. For front view, this is a principal surface, this is a principal surface, this principal surface will fall into line view, as well as this principal surface will fall into line view. For top view, this principal surface will be seen, other principal surfaces will fall into line view. The given surface is a skew surface, this particular surface is skew surface, because none of the edge of this surface is along the principal lines. So, while locating the skew surface, what we will do? We will locate the corners of the surface and then join those corners. So, let us first find out the dimensions of front view, top view and side view. So, we will enclose this particular object in the box. So, complete object is enclosed in the box. So, I can find the dimension 1, 2, 3, 4 is the length, height is 1, 2, 3, 4, depth is 1, 2, 3, 4. So, it is again 4 by 4. So, side view, we will leave one grid space between side view and front view. And front view and top view also will leave one grid space. So, always follow this practice to ensure the alignment in between the object. I know this surface and this surface will be seen. This point is nothing but this point in the front view, this point will be seen here, this point, 2 grid space from here, and I can draw that surface. While drawing this surface, this point, it is 2 grid space from the bottom surface. So, it will be seen at the 2 grid space above the bottom surface. This is top point which will be seen here, this point will be seen here. So, both the surfaces are shown. Now, try to satisfy the principal surface and now if suppose you see this principal surface, it will fall into a line view, this principal surface, it will fall into a line view. So, I should have to show complete line here and then try to satisfy the given skew surface. So, this corner already I have here, second corner I got here, third corner is seen here and fourth corner is seen here. I join all the corners, the skew surface will be satisfied. Coming to the top view, I can see this principal surface which is 2 by 4. Then the skew surface corners I can see here. For example, this corner it will appear here, the other corner will appear here, this corner already we obtained, this corner we obtained. So, we join the corners, the skew surface will obtain. Now, if you see all remaining principal surface are getting satisfied here. Coming to the side view I can draw this principal surface. I know from this corner when I start 4 grid space I have to go, then 2 grid space, then 2 grid space I have to come down. That way I will move So, from this corner if I start, I get this principal surface. Now, let us try to see other surfaces. This surface it is satisfied, then if suppose this surface it is satisfied, this surface it will be seen a line view. This way. Now, if you see the skew surface which will be area view in all the views. So, I have this corner which is obtained, this corner it will appear here, this corner will appear here and this corner will appear here. So, I can simply draw this line. So, area view for skew surface will be satisfied. So, this way we can get the solution for this problem. Let us now see the next problem. Let us discuss the third problem which is shown, and for this problem the direction of observer to see the front view is given with the arrow, and the problem I can see we have principal surfaces as well as skew surface, and we will see how to solve the such problems. So, here we can see the front view, top view and visible side view is the right hand side view. We will follow the third angle method of projections to draw the orthographic projections for this particular object. So, let us first find out the dimensions for given object. I will start from this point which is convenient for me. And go to the back, coming to the front. So, here I have enclosed this particular object in the box, and then we can measure the length. Now, length is the dimension which is across the arrow. So, from here 1, 2, 3, 4, 5, 6, 7, 8 grid space is the length. Height which we can measure 1, 2, 3, 4, 5, 6. Depth 1, 2, 3, 4, 5, 6. So, the box is 8 by 6 by 6. So, I have front view which is 8 by 6. Then right hand side view which will appear right hand side of the front view which is 6 by 6. Top view exactly above the front view 8 by 6. Front view I can see this particular surface which has got the height is equal to 6 grid space and length is equal to again 6 grids. Then if you see this principal surface, it will fall into a line view. These two principal surfaces will fall into line view. So, what is the length of this principal surface? It is 2 grids. For this principal surface, it is 6 grids, that we can see just. So, what we will do? We will try to first draw the now top view and then again coming back to the front view. Otherwise, I can directly draw the front view also by identifying the corners, but from top view it will be more easy for us. So, we will draw these two principal surfaces. This is 2 grid space along the depth and 2 grid space along the length, that we can get the line 2 grid space from this corner along the depth, 2 grid space along the length. Then this principal surface, I have one more principal surface that we will locate later on. So, this principal surface from this corner 6 grid space, from here 4 grid space this point. So, I can 1 2 3 4 5 6 down 2 grid space and 2 grid space here. That we can come. Now, this particular point which I want to mark in the top view I can see only length dimension, not height dimensions. So, I would like to exactly locate these 2 points, this point and this point. Where is the position? What I will do? I will just remove the box and try to locate this point related to this point. So, for this particular object, just for sake of demonstration, I would like to show here from this corner, this point is 1 2 3 grid space down along the height and 1 2 3 grid space along the length. Okay. From this corner I will be able to locate this point 3 grid space down and 3 grid space along the length. Similar way, this point, from this point I can locate 1 2 grid space along the depth and 2 grid space along the length. So, that way we can locate these points. Okay. So, from this corner I cannot see the height dimension, but I see the length dimension. So, from this point I can see the length dimension 1 2 3 1 2 3. This corner will be seen in the top view, and along the depth 2 and length 2. So, other corner is here, and then I can join. So, I can get that third principal surface. Okay. So, I have located that point in the top view. Similar way, I will locate those point in the front view. So, now if you see the front view, I will have to locate these points. I know from the height this corner now I can get in the front view here. So, what I will do, I will draw the front view for this principal surface and this principal surface, which is nothing but a line. Two, 1 2 1 2. So, this is a line. So, now from this corner, that particular point, it is nothing but the 3 grid space down along the height and 3 grid space along the length. So that way I can locate the point. So now try to draw the line view for this principal surface, which is nothing but the height is 1, 2, 3, 4 grids. I can draw the height here 1, 2, 3, 4. Now we will join the corners for this Q surface. This corner it appears here, this corner it will appear here, this corner it appears here, afterwards this corner it will appear here, afterwards this corner it will appear here, afterwards this corner 3 grid space along the height and 3 grid space along the length we have to move, then we will obtain this corner. Similar way, this corner depth dimension will not be seen in the front view, and along the length you have to go 2 grid space. Then this corner it will appear here, this corner will appear here, and that particular surface will be getting satisfied. So let us start from this point. Then 3 grid space down, 1, 2, 3, and 3 grid space along the length, 1, 2, 3. Then 2 grid space down, then 2 grid space here. So this way we can obtain this particular view. Okay. Now coming to the side view, I can see this principal surface. Now this Q surface, this principal surface, this principal surface, this principal surface will be in a line view. So this is only one area view that I can draw here. This principal surface is nothing but a line view which will be seen. This principal surface is a line view. This principal surface will be line view. Again this principal surface will be line view, which is along the height 3 grid space. So that I can locate here. Now joining the corner of the Q surface. So if I see here this corner, automatically I got here, this corner is available, this corner is also available, then this corner available with us, this corner is also available with us, this corner available with us, this corner, yeah, it is this corner. So we can join a line. This corner is nothing but this corner is this corner, and finally this corner will get here. So I can join those corners, and easily our complete view will be satisfied. Now let us complete the top view. Top view is not completed yet. So we have drawn till here. Now we will try to satisfy this Q surface. All corners are available with us. This Q surface, for example, this corner is here, this corner I can see here, then this corner will be seen here, this corner will be seen here, that way. But this principal surface you can see. So well, coming to the front view, and let us see whether it is complete or not. So yet we have not shown this surface, this horizontal surface, which start from here, which I can see, and then running throughout the length, but it is not visible. So it will start from here to here. This part will be visible, but later part will not be visible. So that we have to show here. and that will be shown with the hidden line. Hidden line we will indicate with the red color. So, this line is nothing but this horizontal principal surface. Now, all surfaces are satisfied here. Now, let us discuss one problem on the curved surfaces. So, given object is a single piece object, and for the curved surfaces to find the dimensions we use the center line method, and the arrow indicates the direction for observer to see the front view. So, visible side view is the right hand side view, and we will follow the third angle method of projections. So, let us first find out the dimensions using the center line method. This center I can see here. From this center I will draw the line along the principal axis. So, along the depth I draw the line, then along the height I draw the line, along the depth again, along the height and along the depth. Similar way I will complete object here. Along the depth I can move, along the height and along the. So, length dimension I can get from the depth dimension. For example, I want to find out the total depth. I will just count the grids along the depth. For example, here 1, 2, 3, 4, 5, 6, 7, 8. So, whatever the curved surface is there, it has diameter 8 grid space. For this cylindrical surface which is seen here, it has diameter, outer curved surface 4 grid space, inner 2 grid space. So, radius is 2 and 1 respectively. Height, when I want to find out, I will move only along the height dimension. For example, here 1, 2 grid space is height. For this cylindrical portion 1, 2, 3, 4 and remaining part 1, 2. So, 2 plus 4 plus 2, total height is 8 grid space. So, we will, while drawing, we will start the view where we can see the circles. It is easy for us to draw the view. So, top view I can see the circles. So, outer curved surface, then this cylindrical portion that we can see in the top view. So, let us start with the top view. So, we will draw here the circle of radius 4 grid space. Then inner circle radius 2 grid space, and the hole which is shown, it is radius 1 grid space. Then we can see these principal surfaces. These are the principal surfaces which will fall into a line view. So, if you see the top view, this is a principal surface which is getting satisfied. This is principal surface which is getting satisfied. This is a principal surface which is also getting satisfied. So, top view is complete. Now, let us start with the front view. Front view, this principal surface will fall into a line view. This principal surface will fall into a line view. This principal surface, we can see the area view, and for this curved surface we can see a rectangle, because this is the last visible boundary for the curved surface which will fall into a line view. Okay. So, we will leave the 1 grid space exactly and start the drawing. Height is 8. This principal surface I can draw, which is having height 2, and these two principal surfaces you can see here. Okay, and if you see, this principal surface will fall into a line view that I can draw here. From top to grid space down, I have to draw line. Now further, if you see, there is a hole, that hole will be indicated with the hidden lines, because that is the inner curve surface. Okay, and unless until specified, the holes or slots we consider it is throughout the object, if their height or depth is not specified. So here nothing is specified, so we assume the hole is throughout its height. So that we have to show, and that will be seen as a hidden line. Okay. Coming to the side view, when we come to the side view, I can say this curved surface with outer visible boundary, which will fall into line view. So 2 grid space distance, and this is halfway, half cylinder we can see. So this principal surface will be line view. This curved surface outer visible boundary will come into line view. So accordingly I will draw here. So depth is 8, already we have seen, height is 8, and half cylinder, this is principal surface, this is principal surface. So if you see now, this principal surface which will fall into a line view, this principal surface fall into a line view, this principal surface fall into line view, and this is remaining curved surface. Now let us draw this curved surface. So this is last visible boundary which will fall into a line view, that I can draw here. Height I can get from here, 1 2 grid space, and it will be till here, because object is single piece. The important thing here which is to be noted now, for this principal surface, half part is visible, half part is going inside 2 grid space, that we have to show with the hidden line. But it cannot be like this. Then we have this curved surface, inner curved surface. Okay, for this inner curved surface, this last visible boundary, it will fall into a line view, but it is not seen. So we will show it with the hidden line. From here we will draw it like this, and that is not visible, so it will be shown with the hidden line. Similar way, hole we will have to show, which will throughout the height, because its height is not specified. So these are the lines for hole. So now if you see, all the surfaces are getting satisfied here. So this way we can solve the problems on given curved surfaces. Thank you very much.